What's up, scholars? Welcome back to another episode of one of Miss Atkins' favorite topics.
Hey guys! So today we're going to talk about my topics, but I think this is one of the better parts of this whole unit. So I think you guys will like it. I hope you guys like it.
Perfect. Today we're talking about
triangle proofs.
Yes. All right, 3, 2, 1, go.
All right, so today in our lesson, we're going to talk about our triangle proofs. So what we need to know when doing triangle proofs is that we have two triangles that are the same. So all of their sides are the same, all of their angles are the same. And what we want to do with this proof is prove that these triangles are congruent. So we just want to say in our proof statements that they have the exact same size and the same angles.
Perfect.
I might not even know about it.
Dang it. Okay. So now I'll put the markings on. And we'll talk about what are the sides that are congruent. They're so pretty.
It looks very nice, the blue and the black.
Right? Yeah, geometry is one of the prettiest of the maths.
I think so. I liked calculus, but it was a little...
Calculus is also very pretty.
It was a little...
Okay, I think we are ready to go.
Okay, sounds good.
All right, and 3... Oh, go ahead.
You just want me to talk about which ones are the same, right?
Yep, so say we're given... Here's our example. Say we're given these two triangles. Are these two triangles congruent? I don't know. Do they have all their sides and all their angles congruent?
Okay.
I don't know. Let's see who's congruent to what. All right. In 3, 2, 1, go.
All right, so let's say we're given these two triangles. Well, are these congruent? Well, I don't know, Lisa, are they? So what we want to actually look at is see if their sides and their angles are the same. So if we see side A and B and side X and Y are the same due to their marking, we can then see that segment B and C and segment Y and Z are the same as well due to their marking. So now you would just write segment BC is congruent to segment YZ. And then finally, we can see that segment CA is congruent to segment ZX. So once again, just writing your congruency statement. And then, okay, so we know all the sides are the same. Now we need to see if our angles are the same because you need to have both in order for them to be congruent. So we see that the marking on angle A and X is the same, so those are congruent. We can then see that the markings on angle B and Y are the same, so we know those are congruent. And then finally, we see that our markings on Z and C are the same, so those are also congruent. So now we know that the sides and the angles are congruent, so we can in fact say that these two triangles are congruent. So we would say triangle ABC is congruent to triangle XYZ. And just remember when writing your congruency statement with triangles to go in the same order. So A goes with X, B goes with Y, and C goes with Z. So that's why it's always easier to go ahead and write one angle at a time so that they're in order.
Awesome. That was great.
I need to go take out my dog. Be right back.
Okay.
Okay. Did you hear how my voice started sounding at the end? I was like, Okay, so now we're gonna get now we're gonna get into our actual proofs. So the first one that we're gonna do is something we like to call side angle side. So there's actually four, right? Should we mention that we're gonna learn 5? Or just go ahead and start doing them?
So I think I would frame it as like, God, that was annoying, having to show all of those things are congruent to prove that the triangle is congruent. There's actually some shortcuts.
There's actually some shortcuts to doing that, so you don't have to mention that
Do
each and
all
every
6.
time.
Yeah. You just
Okay.
don't do half as much work. That sounds better.
Okay, so we're gonna do our first example, and that's gonna be side angle side. So what would you guys think if I told you that we could get the same answer with half of the work?
Yes.
Much easier, right? So we're gonna start that here actually with our first example. Should I say what it is before we even start?
Like say what the shortcuts are.
Yes. I could just say like side angle side, and then we could do the example, or you could like write the example and then what, up to you.
Yeah, I think you could say that there's 5 shortcuts,
Okay.
and then we'll write them all out, and then you can explain side, side, side means all the sides are congruent. So if you know all the sides are congruent, you don't have to show the angles are congruent. It's a sneaky shortcut that proves the triangles are congruent.
Okay.
And then same things with all the rest of the letters. So you're kind of explaining what the
Sounds good.
pre-code.
So, okay. Sounds bueno.
Okay, cool. In 3, 2, 1, go.
What if I told you that we could prove that these triangles are congruent for only half of the work? That'd be awesome, right? Awesome. So I'm going to teach you guys some shortcuts so we can actually prove that these triangles are in fact congruent. So we're going to go through 5, and our first one is going to be SSS, or side, side, side. So side, side, side just means that all of the sides in these triangles are congruent or the same. So that's just the abbreviation for side, 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 and it just means that all the sides are congruent. Our next example is going to be side angle side. So now we're starting to see a pattern, but this just means that 2 sides and 1 angle are the same. Usually you'll have your side the same, the angle between the 2 sides the same, and then that final side the same. So this is just SAS. You add some SAS into there. So just SAS, side angle side. Our next example.
Let's just start with these 2, I think, just in case. I just changed my mind. Yeah, I just changed my mind because I forgot we're gonna probably make this into 2 different videos.
Okay, so you can just erase when I said our next example.
Yeah, yeah.
So
these are 2 short.
I was like, Miss Atkin, write it down. In my head, I was like, Miss Atkin, write it down.
Oh, yeah, yep. Okay, so now I need this picture.
Was that okay?
That was great. Yes.
Okay. I just explained how it's usually the side and then the angle in between because that usually helps me. Okay.
Perfect. Yes.
So our
Yeah,
first
all the Lisa shortcuts you can put in here.
Okay.
Are the best.
So our first example is going to deal with so let's do our first example and see which one of our shortcuts applies to this problem. I like doing that better than saying it.
Sure. Yes, that's great.
So if you guys remember from our last lesson, there's actually information we're going to be given here, and we need to prove that these triangles are the same. So we're going to go ahead and write our statements down, and we're going to want to give our reasoning in order to prove that they're congruent. So our first statement says that segment EF is congruent to segment GF, and our reasoning here is given due to the fact that it was given information to us at the beginning. And then then we can go ahead and write that DF is congruent to HF as it was also given to us. Our reasoning here will be given. Are you going to write the statements before or as we go?
I will write them. I'll write them before, because that's how they'll see them too.
Okay.
So we can say, you know, we're going to do kind of fill in the blank proof style.
Okay.
Ah.
Our next statement says.
Actually, no, I just changed my mind. Let's do, we'll write them out.
Okay.
So it'll be harder on the notes than it will be on the questions, which is probably better.
Okay, so we're going to write them out as I'm talking?
Yeah.
Okay. So EF, so then, have they learned about vertical? Yes, we did learn about vertical
Yeah.
angles.
Yep.
So then we finally see that triangles D, F, and E are congruent to what due to the, if now we look at it, we're like, okay, where do we go next? And if we see these two angles meeting in the middle create an X, if we remember from a few lessons back, when something creates an X, we can actually say there are vertical angles there on point F. So we could go ahead and say that angle DFE is congruent to angle HFG due to the vertical angles property, and that would just be our reasoning. And then finally, at the end, we can go ahead and write that triangle DEF is congruent to triangle HGF due to our, and then, so let's go back into our problem. We see that DF is congruent to da-da-da-da, and then we know that F is congruent to the other F, and then that is congruent to that, so we know it's side angle side. Does that all sound bueno?
That sounds good. Yep.
Okay.
All right. In 3, 2, 1, go.
Let's get into our first example. So we want to prove that these two triangles are the same. And once again, like in our last lesson, there was given information to us, and we want to prove at the end that these two triangles are congruent. So the first thing that we should do, let's just go ahead and start with the information that we were given. So it says that segment EF is congruent to segment GF. So if you wanted, you could go ahead and mark this on your actual triangle, as it'll just make the picture clearer in your head. So that'll be our first statement. And Ms. Atkin here is just writing statements on the left, reasoning on the right for your actual proof itself. And then your reasoning here is just given as it is given information. So now we go on to our second piece of given information, and it says that segment DF is congruent to segment HF. So go ahead and mark these on your picture as well. And then you can just go ahead and write that in your statement. And your reasoning is once again given. So now that we have this, okay, where do we want to go next with this problem? So if you look at your picture, these two triangles actually come together to make an X right in the middle. And if we remember from when we learned proofs, when something makes an X, it is actually vertical angles that are created. And vertical angles just means that they have equal value. So we could go ahead and write for number 3, angle HFG is congruent to triangle DFE. And why is that, Lisa? It's just because those vertical angles are congruent. Your property here would be vertical angles. And then for our last one, we actually want to prove that triangle DEF is congruent to triangle HGF. So we can go ahead and write that in our last box. And then, so let's look back at our picture so we can go ahead and decide which one of our shortcuts we can use in this scenario. So we see that H and F and D and F are the same, so that's one side. We see that that angle in the middle is the same. And then we finally see that F and G and F and E are the same. So from the looks of it, we could say that this is side, angle, side, due to the fact that we have a side, an angle in the middle, and then a side next to it. So your final reasoning is just SAS.
Wasn't that so much nicer than having to show that all the parts were congruent, Lisa?
Yes, a lot easier.
A lot easier. Sweet. All right. Okay, I will draw a picture for the next one.
I hope I didn't ramble in that one.
No, that was good. That was
I
great.
forgot how to say, I forgot how to say segment. So I couldn't remember the word for segment, so I was gonna say section, and I was like, that's not geometry. That's not what we're looking for.
Okay, let's do one where they have a side that's shared. So just like the vertical angles one.
Okay.
Why do all my triangles look the same? Golly.
I think you're just used to it.
Just like what comes out naturally.
The next one we're gonna do side, 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 right?
Yes.
So you could just, oh, okay. I was gonna say make two congruent triangles. Just, you know, the first picture that you made and you erased.
Yes.
You could have just done that, but that's good. That's
I think I want them to have to acknowledge that a side that's shared is congruent.
okay.
Just like we had to do vertical angles on the last one.
Okay, sounds good. So we're gonna go ahead and do our next example, and we're gonna want to see which one of our shortcuts will apply here. So we are given two triangles, and we want to go ahead and prove that these triangles are, why am I looking for this? I can't look for this anywhere. We want to go ahead and prove that these two triangles are in fact congruent. So first thing we'll do is go ahead and start off with our given information, and then work our way down to finally be able to prove our statement. ¿Me querías decir algo, mami? No. ¿Qué fuiste a comprar? Como en media hora.
All right, are you ready?
Yes.
Okay, perfect. In 3, 2, 1, go.
All right, so let's go ahead and start our second example. So we want to go ahead and prove that triangle KEZ is congruent to triangle AEZ. So once again, let's go ahead and start with our very first statement. And let's just go ahead and start with our given information for this one. So in this one, it says that segment KE is congruent to segment EA. So let's go ahead and mark that into our picture. Go ahead and make our chart. Once again, statements on the left, reasoning on the right. And your reasoning here is once again given. Let's go ahead and start statement number 2. So it says that segment KZ is congruent to segment AZ. So let's go ahead and once again draw this into our picture. And your reasoning is given. So now let's go ahead and look at this picture and tell ourselves, all right, so we see that we have two congruent sides, but if we look back into our picture, these triangles are actually sharing a side. So if they're sharing that side, it means that it is congruent due to the fact that it is the same side. So we need to go ahead and mark that in and write that as a statement. So segment EZ is congruent to segment EZ. Your reasoning here would be the reflexive property. So the reflexive property just says that when something equals itself, it's just the same thing. I mean, if Lisa is equal to Lisa, then Lisa is equal to Lisa. And if Miss Atkin is equal to Miss Atkin, then Miss Atkin is equal to Miss Atkin. So just remember that for your reflexive. Remember it as a reflection if you'd like. So finally, we can go ahead and write down our fourth statement. And that being finally, our proof. So we want to prove that triangle KEZ is congruent to triangle AEZ. If we look at our picture, it looks like we have 3 congruent sides. So we can go ahead and say that our reasoning here is side, side, side. Why is this side, side, side? Once again, just due to the fact that it has 3 congruent sides in the triangles.
That was awesome. Nicely done.
I said Ms. Atkin is equal to Ms. Atkin.
Yes, I loved it.
You are equal to Ms. Atkin.
I am. Okay. I don't know.
I think it's up to
There's
you. It could do.
I think I want to cut it here.
Okay.
Because this is a hard topic.
It is, especially learning it online.
Yeah. I wanted to take it out because it but then it's not really geometry if you don't do any proofs, you know. Doesn't really count.
We did a lot of proofs first semester.
I know. You lucky dogs.
Oh, I don't know about lucky.
Oh my gosh. I love proofs. But maybe because I've been doing them for a while.
Maybe. I think this is my favorite type of proof. I wouldn't say I like the segment ones. Nah.
Oh yeah, proving triangles is congruent is way more fun.
So then for next time, we'll just leave angle, side, angle, and angle, angle, side. But I think if they have time to pick up this one first, then they'll understand the second one easier, if that makes sense.
Yes. Okay, let's do a quick recap.
Okay.
I also think the recaps have been really good.
Okay.
Oh, I drew on 2 different sides, so I'll be a little awkward.
Okay, so I'm just gonna see what I'm gonna say first.
Sure.
So let's go ahead and do our recap for our triangle proofs. So we first talked about how in order for us to prove that these triangles are congruent, they have to be exactly the same. So their angles and their sides have to be the same or congruent.
That's a lot.
That is a lot.
So
It talks so fast.
it's good.
And we then went ahead and started teaching you the shortcuts, because who doesn't like doing half the work? And we learned about side, 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 and side, angle, side. And side, side, side just means that all the sides are congruent, and side, angle, side means that 2 sides and the angle in between is congruent. So we can see that with our first example where we did side, angle, side. And then our second example in which we did side, side, side.
So also want to remember that we use the vertical angles here.
Okay, remember that we used the vertical angles there because it created the X. And then for the next one, we use the reflexive property, which just means it's itself. Okay.
Yep, so those are the 2 things you want to look for. You'll be given stuff, and then you want to look for vertical angles and shared sides, because those are things you can also mark in your picture.
Okay, sounds good.
Okay. All right. In 3, 2, 1, go.
All right, so let's do our final recap for our triangle proofs today. So in order for us to be able to do a triangle proof, we have to prove that these triangles are in fact congruent, which means they have exactly the same angles and sides. So angle, 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 side, 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 side. So Ms. Atkins says it's too much, which it kind of is. Kind of is. So what did we do next? We did our shortcuts, because who doesn't love only doing half the work for the same answer?
Amen to that.
So our first example that we worked with was side, angle, side. So that just means that the two sides and the included angle in between is congruent. In this example, we talked about vertical angles, and you want to look for those in your example so you're able to use them in your proof. It just means that we created that x and those two angles are congruent. So in this example, we got side, angle, side. With our next example, we worked with side, side, side. And just remember that when working with side, 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 include your given information, and you'll want to look for the reflexive property. So this just means that something is itself. In this case, it was EZ. And finally, our answer, side, 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 we have 3 equal sides in both triangles.
Beautiful. All right. Now let's go back to the Galerator. All right, scholars, you made it through part 1 of one of my favorite topics, triangle congruence. How'd we do, Lisa?
I think we did great, guys. I
Yeah.
think that lesson will hopefully be smooth, maybe not, but just keep working through it. Email Miss Action once again, work through your examples, and then we'll be back for part 2.
Perfect. Love you. See you later.
I did too.